Hi, I'm Beth Wenzel, Project Manager at the Milwaukee Metropolitan Sewerage District. I'm excited tonight to be able to share some updates about how we've changed course in developing a plan for fish passage around Kletzsch Dam. But since fish passage at Kletzsch is a project required to address the Milwaukee Estuary area of concern, I want to start with a little background on that program. An area of concern is an area on the Great Lakes that has a history of significant environmental degradation from human activities, which limits our use and enjoyment of the local waterways. They were identified as part of the Great Lakes Water Quality Agreement between the United States and Canada in the 1980s. This map shows those highly degraded shoreline areas in the US. There are also 12 areas on the Canadian side of the lake that are not shown here. Wisconsin had 5 areas of concern, but the lower Menominee River was removed from this list in 2020 because its significant impairments were fixed. Our objective is to fix the impairments in the Milwaukee Estuary and take it off the list too. So let's talk a little bit about the Milwaukee Estuary. The blue shaded areas on this map are watersheds for the 4 major rivers that flow to the Milwaukee Estuary. And of course, when I refer to a watershed, I'm talking about the land area that drains to each of those rivers. So for example, any rain that falls within this area, which is the Menominee River watershed, any rain that isn't soaked into the ground or otherwise captured ends up flowing into the Menominee River. The Milwaukee Estuary AOC includes areas that are shown in yellow on this map. They are areas that are targeted for cleanup of historical contamination and degradation that I mentioned previously. The estuary area of concern includes portions of 5 rivers and creeks, and it includes portions of 2 counties, Ozaukee and Milwaukee counties, and 13 municipalities. Our goal is to fix the Milwaukee Estuary so it's no longer on this list of Great Lakes areas of concern. In order to do that, we need to clean up our waterways by improving water quality and removing or isolating contaminated sediments. We need to restore and reconnect fish and wildlife habitat. And it's not enough just to restore the habitat. We really need to show real increases in the numbers of targeted fish and other animal species. And we need to ensure that water is clean enough for swimming, boating, and fishing. Restoring fish passage through Kletzsch Park fits into that middle category of restoring and reconnecting habitat. Accomplishing the important work necessary to get Milwaukee off this list of degraded areas requires a lot of collaboration from a lot of organizations. The Milwaukee Restoration Partnership is a group of established partners in the community who have been working together for years to improve water quality in the area. It is made up of area of concern project sponsors as well as other governmental and non-governmental organizations actively participating in area of concern work groups and includes over 150 individuals from more than 20 organizations, and they are identified here on this slide. If you'd like to continue following the work of the partnership and learn about ways you can get involved, you can email the partnership at this address and get yourself added to the email news list. You can also visit the website, and that's shown here as well. So now let's talk specifically about fish passage at Kletzsch. I want to start by illustrating why fish passage at Kletzsch is important. This is a map that shows the watersheds and rivers of the area. I stripped out the roads and municipal boundaries, so it looks a little different from most maps of the area, but you might recognize the rivers and watersheds from the slide I showed previously. Before we manipulated the river, fish would migrate from Lake Michigan up the Milwaukee River and reproduce up in the upper portions of the watershed and in several of the tributaries. When we built a lot of dams along the river, we disrupted those migrations. Several dams have been removed and others have had fish passage routes built around them. So the only 2 barriers that remain between the lake and Bridge Street Dam in Grafton are Estabrook Falls and Kletzsch Dam. So currently very little of the river is accessible to fish that are coming up from the lake. but if you joined us in our meeting last week, you know we are working on creating fish passage at Estabrook. And if we can also get fish around Kletzsch, we make the river accessible all the way to the Bridge Street Dam in Grafton. So this includes areas just downstream of Bridge Street and in the lower portion of Cedar Creek, which, based on some habitat mapping that Ozaukee County has done, we know are very good for sturgeon reproduction. And many of you are aware that restoring a lake sturgeon run in the Milwaukee River is a priority and a very exciting opportunity. We also, if we can get fish around Estabrook Falls and Kletzsch, we also make several tributary streams accessible, which are connected to large wetlands, and those are great for wetland spawning fish like northern pike. Uleo Creek up in this area is connected to a very expansive wetland that is productive northern pike spawning habitat. And Pigeon Creek has some really high quality habitat as well. Because these reconnections are so important for healthy fisheries, fish passage is a regional priority. And as I mentioned previously, it is required to address the Milwaukee estuary area of concern. So unless and until we can get fish around Kletzsch Dam, people will be continuing to talk about how to get fish around Kletzsch Dam. Many of you know that there's some history associated with developing a design for fish passage at Kletzsch. Between 2017 and 2019, Milwaukee County Parks and its partners explored several fish passage options for Kletzsch, and they primarily included a channel on the west side of the river or a channel through the dam. Early in 2020, due to public opposition to the feasible alternatives identified, the project was put on hold. Now, one clear message that came out of the public comments was interest in developing a fish passage on the east side of the river to avoid disturbance to the west side. A couple of barriers to that approach were the need for more real estate to work with on the east side, and I'll point this out in the next slide, as well as the need to avoid increases to the regulatory flood elevation. Because these are issues that MMSD has extensive experience with, MMSD was brought into the project, and in late 2020, the county and MMSD leadership agreed to shift to MMSD as project manager for developing fish passage at Kletzsch. So in 2021, MMSD purchased a property on the east side of the river, which created enough space to develop a feasible passage. And we are currently developing a design on the east side of the river with review and support from the county and DNR. So this is the project area we are considering. Just to back up, so these two parcels, the southernmost parcels within the project area, are the two that are owned by Milwaukee County. But those two alone are not enough space to create the fish passage. MMSD recently purchased this parcel in the middle, and this northern parcel is owned by the city of Glendale, and they have expressed support for exploring an option for passage on the east side and indicated a willingness to potentially use a portion of that parcel for that use. There are a few tasks that we've completed already, and there is a lot of work currently underway. As I mentioned, land acquisition is complete. We do have enough room to develop a fish passage on the east side. And we are exploring options for construction and maintenance access to get in there and do the work that's needed, both to construct the fishway, but also to maintain it in the long term. We also have completed several investigations related to getting a project over here permitted. And I won't go into a lot of detail on those investigations, except to say that we've not come across any red flags. I know concern about disturbance of Native American cultural resources was an issue with work on the west side, but UW-Milwaukee has completed field work on the east side and has not found anything that would be a problem for us to construct this project on the east side. The engineering and design is underway, and I want to be specific. The project that is being designed includes the Fishway, and it includes some necessary dam repair. We are not continuing work on any portage or trails at this time. Anything on the west side that the county may do in terms of park amenities would be done, through a separate process in the future. And with that, I'll turn it over to Nick Jordan with Interfluve to share some additional information about the engineering and design work that's underway.
Hi, I'm Nick Jordan, project manager with Interfluve. We're the design firm assisting MOSD with Fishway engineering and design. Over the next few minutes, I'll be discussing some of the project's goals, design criteria, and just a few of the technical engineering elements that go into the Fishway and its design. So let's start off with identifying the project's objectives. The primary project objective is to create safe, effective, and timely fish passage at Kletzsch Park Dam. And we mean very specific things when we say safe, effective, and timely. By safe, we mean that the fish will be able to move through the fishway without being injured or suffering predation. By effective, we mean that we want a certain proportion of the fish in the river to be able to find the fishway and successfully navigate the fishway. By timely, we mean that we don't want to delay any critical life stages for the fish. And here we're primarily concerned with migration upriver to spawn in the spring. The two fish species that we're considering here in great detail are northern pike and lake sturgeon. We'll be going into a few of the details on these in the next few slides. The important thing to understand is that they're relatively weak swimmers. They're ecologically important in the river, and we consider these because if pike and sturgeon can get through a fishway, it's a pretty safe assumption that other fish such as walleye, trout, salmon, etc. will be able to successfully make it through the fishway. Now, there's a second goal to this project, and that's to implement needed repairs to Kletzsch Park Dam. And this won't be the focus of the presentation, but in brief, the repairs will consist of removing some sediment that's built up behind the gates of the dam, making sure that the gates are operable, and then doing some masonry repair along the east abutment. So as I mentioned, the two target species we're looking at for this project are lake sturgeon and northern pike. And these species were selected because they're ecologically important within the Milwaukee River watershed. And the DNR's efforts to restore the lake sturgeon population in the river and open up accessibility to spawning grounds is a really critical consideration for this project. Lake sturgeon and northern pike both move upstream to reproduce in the spring. And so we're really considering the spring flows when we are identifying design criteria for these fish. Again, these are relatively weak swimmers. They can swim into a current of about 4 to 5 feet per second for a short period of time. Then they need a while to relax and recuperate before they can swim that fast again. And so they're also relatively poor leapers. Sturgeon like to cruise along the bottom of rivers. They don't really jump over barriers, and neither do northern pike. So the thinking is that if these two fish can pass through the fishway, the walleye, trout, salmon, and other fish will also be able to make it through the fishway. And so what we did early on in the project is establish design criteria, which will allow us to evaluate whether or not we met the project goals. So for sturgeon and pike, because they are relatively weaker swimmers and they can't leap over barriers, they need deep water, so they need to submerge their entire bodies and achieve their full swimming performance. They need slow water, so the maximum speed within the fishway can only be about 4 feet per second. They need resting areas. As I mentioned, they need an area where they can hang out, wait, and recover their strength before they move over the next section of fast water. There can't be vertical barriers because these aren't jumping fish. The overall fishway slope needs to be less than 2%. And then the outlet of the fishway needs to be near the base of the dam, so the fish, as they approach the dam, won't miss that attraction signal, and they can find the fishway easily. So early on in the project, it was identified that a Naturelike Fishway is going to be the best way to achieve the goals at Kletzsch Park Dam, especially on the east side of the river. A Naturelike Fishway is kind of what it sounds like. It's a fishway that mimics nature. It's not a fully naturalized channel, but it's made of natural materials like stone and earth, and there's usually vegetation planted along the banks. Typically, a Naturelike Fishway is very similar to what's shown in this conceptual textbook drawing. The main river flow is moving down the screen, and the fishway essentially consists of a channel that's dug around the dam, and a certain amount of flow is diverted through the fishway. There are faster sections of water, kind of shown with these little stone hatches, and then there are slower pools where the fish can rest before moving up the next step in the fishway. The fishway entrance is typically located close to the base of the dam or weir, so that the fish, as they move upstream, can swim along the face of the dam, then find the fishway and move through it. Typically, the slopes of these fishways is fairly low, especially considering the relatively higher slopes of other fishway technologies. Now, there is a Naturelike Fishway that's been built on the Milwaukee River at Mequon-Thiensville Dam, which is the next barrier upstream from Kletzsch Park Dam. The Mequon-Thiensville Fishway was built about 10 or 15 years ago, and it's worked well over that time to pass a number of fish through the fishway. It's recently actually undergoing some repairs to improve its ability to pass sturgeon. So we're really hoping that sturgeon in the very near future will be able to get up to the Mequon-Thiensville Fishway and utilize that improved fishway design. So when we apply that Naturelike Fishway concept to Kletzsch Park Dam, we came up with basically the figure that you're seeing on the right. And this is a simplified version of one of our preliminary engineering drawings showing the grading contours for proposed conditions. Now, the black lines shown in this image are the contours for the grading surface. And I'll highlight some of the key features here. The blue line indicates that flow will be coming in from upstream and moving downstream of the dam. We expect about 10% of the overall river flow to be moving through the fishway at the average spring flow conditions. The orange boxes that you see represent the riffles, and again, these are the steeper sections of the channel that will have faster moving water. The blue pools then will have slower moving water, they'll be flatter. And these are the resting areas that are really important to achieve fish passage at the dam. The overall slope of this fishway then is about 1%, which is a little bit steeper than the main stem of the river, but overall is relatively mild on the spectrum of fish passage technology. And that's a really positive thing for the northern pike and lake sturgeon. When we look at a representative cross-section taken through one of these riffles, it's apparent that this is a pretty robust design. We'll be designing this fishway to withstand every flow that might occur up to the 100-year event. And this means that we have to design the fishway out of rock that's big enough that it won't move during some of those flood flows. Some key features that I'll draw your attention to in this engineering cross-section. We have boulders that are going to be keyed into the riffle, and these will break up the flow, and these will also provide some smaller hiding spaces within this faster moving section of water. We'll have a couple different slopes to optimize the hydraulic design of the channel. Then we're also going to use some bioengineering techniques near the top of the bank in order to get vegetation to establish quickly and provide resistance to shear stresses and velocities that might occur during flood flows at the top of the bank. So after this is constructed, it'll be a mostly rock channel. Then at the top of the bank, we'll have shrubs and trees and native grasses and that sort of thing. To evaluate the project, we use a couple different hydraulic modeling techniques. These are computer tools that are powerful ways of analyzing hydraulics within the river. The two-dimensional hydraulic modeling figure that you're seeing on the left shows the velocities moving through the river at the average spring flow. And you can see that these yellow sections indicate some higher areas of velocities. These are over the riffles, and then there are pools where there's some lower velocities. We're also using these 2D modeling results to evaluate the design with respect to flow depth and flow velocity and the distribution of flow through the fishway and in the main stem of the river. We also use one-dimensional hydraulic models to verify the flood elevations of the project. Some of you may recall that some of the previous options we looked at in earlier phases of the project had some difficulty meeting floodplain regulation requirements. And we're happy to report that this East Bank alternative is meeting floodplain requirements and won't cause a rise to that regulatory flood profile. So with that, I thank you for your time, and I'll turn it back over to Beth. Thanks.